Hello, hello. So today we're doing an experiment here on air pressure. So you might be wondering, hey Jim, why do you have a plate with water in it and a candle sitting in the middle of the plate? Don't worry, you'll see. You'll see. We also have a glass here, a big glass at that. Looks like something you might get in a bar if you have a nice alcoholic beverage. If you're 21, you know. And we'll be using that for this experiment as well. And we'll also be using this lighter here. We'll be using this lighter. I did not have any food coloring for the water. You know, I didn't really think it was that necessary, to be honest with you. I thought it'd be fine without it. And you'd still be able to understand the experiment. So I did not worry about food coloring whatsoever. And then also we have another experiment. We have two, believe it or not, we have two experiments. Here, you might be asking me, Jim, hey, why do you have a water balloon wrapped around the lip of a water bottle? Actually, this isn't a water balloon, this is a party balloon. But I learned that the hard way at Walmart. But nevertheless, yeah, so we're gonna be testing this. This actually is a secondary experiment with air pressure, and you'll be able to see it. So it'll get pretty interesting. But for the first one, we're gonna start with the candle. The candle's pretty simple, pretty easy to understand. Actually, this one's a bit more easy to understand, in my opinion. But you know, it varies from person to person. So yeah, we're gonna start with the candle. So first things first. In case you want to do this at home, just get a plate, fill it up with water, and actually first and foremost, you should probably put your candle down on the plate, in the middle of the plate, or somewhere close to the middle. And then put the water and fill it in around it. Make sure you have a big glass that will fit completely over top of the candle. Make sure it fits completely over the top of the candle, right? And your lighter. So we're gonna start, we're gonna light it. You can tell I don't use lighters very much, huh? Make sure it's lit. Okay, good. Now it's lit. Don't tell housing. So now we're gonna see. We're gonna throw this over top and see what happens to the water. So pay close attention to the top of the glass, which is going to be at the bottom, near the bottom lower part of the candle. Okay. Right. So now there is no oxygen. The oxygen is being eaten up by the candle, by the actual fire. You can see actually the candle's gas filling up and rising to the top because the hot air is now rising to the top. And most importantly, if you look at the bottom here, seeing this here, that is all water that actually has risen up. So I actually have some notes here. If you could see that now it's created its own atmosphere. It's created its own atmosphere. And because it's totally sealed and encased, it wants to take up that remaining space that was eaten up, right? So the water will rise to take up that space. The hot air rose, and the water level rises to compensate for that hot air rising to the top. It's pretty cool, really cool, honestly. I thought that was pretty cool. And as you'll see, when I'm gonna lift this off, and you'll see the water, as soon as this basically artificial atmosphere is removed, meaning lifting up the glass, the water will sink back into the plate, and it'll be as though nothing happened. And also the gases from the candle will be gone. The candle wants to come with it. And there you go. You see that? It's a good candle. I'm gonna wave this around a little bit. Don't want to set off the fire alarm. But yeah, there you go. So that is experiment number one. That is the candle and a bottle in the water. Or glass. Yeah, it's glass. So number two, we're gonna leave this here because I don't want to spill water all over my desk. But you know, we'll slide it a little bit. I already got a little bit of water on the desk. But that's okay. Nothing that towel can't fix. And here. So this is our bottle. This is experiment number two. Here we have just a Monster bottle. Monster makes it really firm, like it's hard to, at least at the bottom, which is most important for this experiment, because that's where I made the hole and incision, which I'll show you in a second. It's stiff. You need a stiff bottle. I tried doing this with a Propel bottle earlier, and no, way too flimsy. Way too flimsy. But this, stiff. Genuinely stiff, which is what we need. Now, what I did was I put a water balloon at the very top of this. I put a water balloon at the very top of this. I didn't want to waste your time putting all this stuff together, you know. I'd rather explain it, and you'd very easily be able to do this yourself. It's all at home kind of stuff. So, got the water balloon, put the head of it, the top of it inside, and folded the bottom base where you'd usually tie it up so that the air stays in, folded it around the lip of the bottle, as you can see here. So that's what I did for that. And then if you look here closely at the bottom, you see that little scratch looking thing? See that? I got a pocket knife out and I actually cut a very small incision right there. Very small incision. So, yeah. And also we're gonna use, we'll see if it works. It might not, might need more water, but we have two, not just one. Oh, spilling more water. 2 Dixie cups worth of water here, which I'll get to in a second. And you'll see it's gonna be pretty cool. So, in any case, right here, we have our water bottle with the balloon. So what we're gonna do is we're gonna push air from our lungs into this water balloon. Water balloon. I keep saying water balloon. Air party balloon. You'll see. Fills up a little bit. You can actually hear the air coming in and out, right? Well, that's because you might be thinking, Jim, that shouldn't be possible. Remember, I did not have that hole covered. When I do have the hole covered, and I try to blow into the balloon, you'll see what happens. Looks so silly. Nothing. You can't do it. There is no place for you to push air into this balloon to then push out the remaining air that is already inside of the bottle by sealing this hole right here shut with my thumb. So there is no way for the air to escape. Now, we can get even more creative, and I'm going to show you something in a second here. It's going to be pretty cool. So what we're going to do is we're going to push in, we're going to blow in air, using our lungs, of course, into this bottle. But once we do, while we have this hole open, once we get it filled up pretty high, we're going to close the hole and see what happens. So I'll do it this way, so you can see. Make sure I got my phone here. So there you go. See? It kind of filled up a little bit. Now we can actually do it again. So I'm going to put my lips back on this. I'm going to fill it up even more and keep blowing into it and then reseal that hole again. Look at that. Now my thumb isn't completely covering it, so you can hear a little bit of air squeaking out, but for the most part, there is barely any air getting out there. But yeah, you can hear that tiny little annoying, like, baby frog croaking noise. Yeah, that's a tiny bit of air escaping right now, unfortunately. But yeah, that's how it goes. So yeah, and now we're gonna test it out a different way. You might be thinking, okay, what else can we do? Well, I'll show you. Also, there's the air escaping after I released my thumb from the side, and there it is. That's all the air that I blew in from my lungs into here. So, if this is true, that if we blow in and cover the hole to keep the air in, the reverse must also be true, that we can pull with our lungs air out from the tiny hole and keep it stuck in there. Because we are basically, what we'll be doing is taking air out from the bottle, not from the balloon. We're not putting any air or pulling any air out of the balloon. The air in the balloon is, you know, not being messed with by me. The only air that I'm messing with is the air in the bottle, completely separate from the balloon. So you'll see here, I'm going to suck the air out from this tiny, tiny scratch looking hole here. Now it's not gonna go very well. Actually, it might take me a bit to really get a good chunk of this air out, but you'll see in a second here what I'm about to do. So it's gonna probably take a couple tries to really get this to be at a noticeable different size level. So pay close attention here as to how big it is. All right, now we're gonna try to pull this air out from the bottle using this tiny little cut that we made before. As you can see, you hear that? There's a little bit of water in the balloon. I was kind of testing this earlier, so I was making sure that it would work appropriately. But yeah, there's a tiny bit of water in the balloon, so you might hear it sloshing around, but it is stiffer. It is thicker. Right? I let go. Yeah. I kind of shrunk a tiny bit. It's very difficult to be able to fill this up the opposite way. We'll try again, see if we can get more to fill up. So yeah, it's kind of important for the last part, so bear with me for one moment. So yeah, honestly, I'm kind of struggling with that part, to be honest. I kind of made the hole a little bit small, so I think we're gonna scratch the water idea. But essentially the idea behind the water was that we were gonna put water into the balloon while it was like deflated, or like inflated, but by pulling air out from here. Actually, we can do it the other way. Let's see if we can do it this way. That air in. We're going to really fill this air up. So of course, what I wanted to do is do it the other way, which is pull the air out from the bottle, but instead we're just going to push the air in from the top of the balloon. It's a bit easier, but I'm glad you were able to see the fact that you can also pull air out from the bottle. Maybe this one is a bit more complicated, huh? Yeah, so what we're gonna do now, keeping this hole covered, we're going to put this water from these Dixie cups into the balloon. We're filling up the balloon with water. Now we're gonna use another Dixie cup. We're gonna use 2 of water. Now hopefully, if I am correct, which I might not be, we'll see, it should be able to hold the balloon down. As you can see, look at how strained. You can see here at the top here, where this kind of tongue lip is here. See how strained that is, right? So we're gonna let go. Oh, it happened. Okay, I thought that might happen. So the air pressure actually was stronger than the gravitational force, which is pretty crazy, right? I thought I might need more water. But then again, it might not have been a thing of water. It might just been that no matter what I did, that air pressure was gonna come in and completely and utterly take out as much water as I can. So we're gonna do this. There. I basically created a resort for myself here with all this water that I used. Sorry, Africa. But yeah, those are 2 air pressure videos. I really hope you enjoyed them. Honestly, I had actually a pretty good amount of fun making them. It was a bit last minute. I had to get some supplies from good old Walmart. But nevertheless, yeah, it looks like we got everything done, got everything together. And yeah, I really, really hope you enjoyed. And I really hope you learned something, that air pressure is very much so real. And it's very easy for us to take it for granted. and not really understand the significance of how it plays a role in our daily lives, and how atmospheric pressure and all kinds of different things can come into play, and just how easy it is from home to set up little labs like this. So yeah, I really hope you enjoyed, and thank you for watching, thank you for listening, and take care and have a nice day. God bless you.